How's it going, guys? In this video we're going to do a really quick overview of phase diagrams. So first off, on the y-axis we're going to have pressure, and on the x-axis we're going to have temperature. From there we're going to have up here anything that falls into that level of pressure versus temperature is going to be solid. In the middle here is going to be liquid, and down here is going to be gas. So from there we have some of the state changes. So I'll draw in the arrows first, and then so here we have from, let's say, from liquid or from solid into liquid, we have melting. From liquid into solid, we have freezing. From liquid into gas, we're going to have vaporization. And then from gas into liquid, we have condensation. These are the weird ones. We have when solid turns into a gas directly, that's going to be sublimation. And then when we have a gas turning directly into a solid, that's going to be deposition. Okay, now from there we have a few pretty significant points right here. That's one of the most important points. That's called the triple point. The triple point is the one spot on this whole phase diagram where all three phases can coexist at equilibrium. So there could theoretically be like an ice cube floating in liquid water with water vapor floating all around, and that's the triple point. Now we have a few others up here, right, kind of like at the end of this. You can draw like a dotted line up, a dotted line across. There, right here, is what we call the critical point. The critical point is essentially the highest temperature that you can liquefy a gas. And then everything over here is the supercritical region. The supercritical region is really cool because there basically is intermediate behavior between liquid and gas. So essentially anything that you know about liquid or gas in terms of, you know, the laws of physics might be blurred in that kind of region there. It kind of is bent. Now, other than that, there's a few kind of significant things to keep and watch for. If you're asked, for instance, to identify what is right here, where are we in this part of the phase diagram, you're on the line between liquid and gas. So essentially, liquid and gas will exist in equilibrium in those spots. Same thing with like here and here. Any line that borders two separate regions or phases, that's going to be the case. So other than that, I think there's just kind of, you know, that pretty much boils down the majority of this. There's just kind of a couple other quick fun facts that are kind of interesting. You can actually turn like a gas directly into a solid without changing its temperature at all, just by affecting the pressure. And that's true of any of these things. I think it's pretty interesting. For example, you know, if you're asked right here, if you're in this spot in the phase diagram and you're in a gas state, can you keep the temperature consistent and only change the pressure and get it into a solid? Yes, you can actually do that. You just, you know, increase the pressure greatly. You would actually be able to move across the line like that. And that's actually why at higher altitudes the atmospheric pressure is lower, so water boils at a lower temperature. So basically boiling point, when you go, you know, from liquid or vaporization point, the boiling point is the point at which vaporization point is equal to atmospheric pressure. So when atmospheric pressure is lower, it's going to boil lower. So that's kind of a quick overview of the phase diagram.